In this 1986 FRQ from AP Physics B, now we cover this part or this topic in AP Physics 2. So in this question, they say an object is placed 3 centimeters to the left of a convex convergent lens of a focal length of 2 centimeters as shown in the picture. Sketch the ray diagram on the figure and construct the image. It may be helpful to use a straight edge, and then determine the ratio of the image size to the object size. If I did this question on the AP exam, you have to have the ruler to be exact. So I'm going to start with calculations first before I do my drawing. I'm going to use the lens equation, which is 1 over the focal point is equal to 1 over dO plus 1 over di. The focal length is 2, and the distance to the image to the object is 3, and the distance to the image we're looking for. I'm going to times my equation by 3, so there's 3 terms in my equation, 3 fractions. I'm going to times them by the common denominator by 6. So the common denominator is 6, so every single term is going to be times by 6. 1/2 times 6 gives me 3, equals to 1/3 times 6 gives me 2, and then I have the last one, 6 over di. Subtract 2 from both sides. Then I have 6 over di. So that gives me the distance to the image is 6 centimeters. So now when I do my graph, I have to follow the ray diagram rule. It's going to be the parallel one, and then through the focal point. So the focal point is 2 centimeters. So here is the focal length, and here is the focal length. So I'm going to go through the focal length. Then I have to go through the center and through the focal length, and then parallel. So looks like my image is appearing somewhere right here. And if you count from where the lens is located at 3, then the image is appearing 6 centimeters away from the center of the lens. And because the image is appearing where the rays are meeting, the image is inverted, then this image is real, not virtual. And now I have to determine the ratio of the image to the object size. So I have the magnification formula, which is negative di over do, and that is negative 6, and the distance to the object is given 3 centimeters, so that gives me negative 2. So the size of the image is twice the size of the object, and the negative sign stands for the inverted image. So that you have to pay attention to the negative, so that means it's inverted, and it fits our drawing. For the next part, they say the convergent lens is removed and a concave divergent lens of focal length negative 3 centimeters is placed as shown in the diagram below, and then sketch the ray diagram for the figure above. Calculate the distance of this image from the lens, and then state whether the image is real or virtual in this case. So at first I'm going to place where the focal length is, and it is 3 centimeters. So right here, I'm going to have 3 centimeters. And then for the ray diagram, I will have, actually let's do calculations first so we confirm with our work. In the divergent lenses, our focal length is on the same side as an object, so our focal length is going to be negative. So we have negative 1 over the focal length, which is 3, again keeping it in centimeters. 1 over 4 DO, and looks like the object is 6 centimeters away in this case, and plus 1 over DI. And again, I can times every single fraction by the common denominator. So common denominator is 6, so times it by 6. And we will get negative 2 equals to 1 plus 6 over DI. And that will give me negative 3 equals to 6 over DI. And DI is equal to negative 2 centimeters. And that tells me that the image is gonna appear on the same side where the object is. I can calculate the magnification of this image, so it's negative DI over DO. I have negative 2 over the distance to the object is 6. So the magnification is 1/3. Because there's no negative in front of the magnification, I know that my image is going to be upright, and it is going to be 1/3 of the size of an object. So let's do the ray diagram now for the divergent lenses. So the first one again is going to be parallel. And here you have to think about which focal length you're going to choose. I choose the focal length of the side of the lens that it hits first, because this is the curvature. So that means the circle goes like this. Then I choose my focal length on this side. And that's another reason why it is negative. So the ray is going to be diverging. So I'm going to use the focal length as my reference and what direction it's going to be divergent. So it's going to be going in that direction. Then it has to go through the focal point to and then parallel. So for the next one, for the focal point, I'm going to use the next focal point because I used the first one. Now I'm going to use the next focal point. So my graph, my line, the ray, is going toward the focal point, that one. And then it has to go parallel. And then the last one is I have to go toward the center. And let me show that if so here is the line where it appears. So on the other side, if the eye was right there, then the eye would think that the image or the object is located somewhere on the purple line, the dotted purple line. If the eye was at this position, then the eye would think that object is positioned somewhere on the next dotted line. And then for the last one, I have to place it through the center, and when it passes through the center, it doesn't refract. So the ray would go this way. And I see that all the rays, the dotted lines, and the last ray, they meet at the position over here. And you see that the distance is negative 2 centimeters. So that means the distance is negative 2 centimeters from where the lens is positioned. So this is negative 2 centimeters. So that means I found my location of my image, the right position, like the way I calculated it. And my image is 1/3 the height of my object. And it is virtual because this is not where the rays actually meet. This is where the rays appear to meet. And the image is upright because our magnification was positive. We can see that the image is also upright. For the next part of the FRQ problem, they say that the two lenses are the object and the object are then placed as shown in the picture. So the two lenses and the objects are placed as shown in the picture right here. So what we want to do is to construct and complete ray diagram to show the final position of the image produced by the two lens system. So the first lens had the focal length of 2, and the second lens had the focal length of -3. And if I construct the drawing for the first lens, again, it's parallel through the focal length, through the focal point, or through the focal point, and then parallel, or through the center without refracting the ray, I would get my image over here. Let me do it in different colors. So let's do, before we do the final image. So we would get the image over here. And now if this becomes an image for the next lens, let's do it in different color as well. So I'm gonna do the parallel, and then I have to do through the focal point. So I'm gonna use the focal point here as a reference to diverge my my rays. And then the second one has to go through the center. So the second one is through the center, and that one is passing without the refraction. And the last ray has to be coming toward the last focal point. So the ray is going toward the focal point this way. And then, so that would be toward the focal point that way. But then it has to go parallel to the axis. So for the observer, this ray would come from this direction. For the observer right here, this ray would come from this direction. And for observer right here, this ray would come from this direction. And observer right there from like straight line. So the final image of from two lenses would appear somewhere over here. So this would be the final image of the object that is placed where we have its original position. And I think that's all we had to do for this question. I like this question because it had convergent and divergent lenses at the same time, so it's a good practice of both lenses. And so that was all we had for this question, 1986 from AP Physics B. Now this topic is covered in AP Physics 2. And thank you for watching, and I will see you in my next videos.